Hey, so the idea here is to take advantage of Ubuntu 25.04 coming out yesterday and doing something that I wanted to do in the graphic talks before. For Excel, the meetup itself was fantastic, but it didn't go as well as we were hoping because nobody came in August, but part of life. So the idea is that I wanted this one to show how I do like this guy, a GLmark test on the host. Okay. I'll just wait a little bit for it to show like the frames. How I do it like on Docker. So here we can see we have like a GL renderer. If it's not llvmpipe, then it means it's graphic accelerated, and you need to provide several things. If you want to put it like in a Docker, or you want to forward it from QEMU or something like that. I will not go all over the test, but then you will find some other things. So the idea here is that I want to go ahead and run it in the Docker, and that I'll show the Docker file for. And it will do the same. We can see the accelerator here. Okay, here we can see that the GL version, it's 3.2, but we can see that my host runs Ubuntu 24.10, and this runs 25.031. This is the name of like the Docker version there, but probably the Docker Hub did not update it yet. Okay, so you can see the frame rates are pretty much similar. In one of the tests, it was better for the host. In the other, it was better for the target, but it doesn't really matter. All right. What matters, you know what? I will let it run a little bit and show the Docker file, because, like, why not? Yeah. So I'll put it like on the side. So if you don't know like this graphics, you'll continue like seeing that. I know it exists because it's already open. And look at the Docker. Like we take like this. And we have like the update, and we install because we use only Wayland, not lib Wayland DTL, the GLmark test, both for Wayland because I want to show something on it, and for ES2 Wayland, and the Mesa drivers. That in this case is just part of the package. Sometimes you will need for your own package to put some other things, and these are additional packages that we have. Here we will give it via command line actually, so we don't really need it, but that's fine. And it ran automatically because I gave here like the command. Okay, so I'll let it run like in Docker, and you know what? Now I'll just quit it because we've had enough. So having said that, I want to go ahead and just instead of running glmark ES2, let's go and run glmark Wayland. We're convinced that things work. I'll explain why a little bit later. And then I would go say, hey, you're loading GL library. So there are several ways to debug something like that. One of them would be stracing glmark 2. Wayland. And we will look for errors. And since I know what is missing, and I know that it's one of like the OpenGL libraries because it said about it, then we can look for failures. So it fails to find libgl in several places. It's not libgl, yes, it's libgl. So we need to figure out who provides that. Now I already know that which provided is libgl1. So I'll just install it. And we will indeed see that once I do it, then it actually works. I don't need the strace. And we have this, and the frame rates will be pretty much the same also. All right, the test is very similar. Okay, and there is no something too complicated. So that's it. Now, what if I didn't know it? Okay, what would I do? So something that one can do can be installing something called apt file. Okay, so it's heavy. It's 52 megs before getting the caches, and another 100 caches or so after getting the caches. So you can see here that now it's 375. If I go ahead and try to find the library libgl, it will tell me, hey, you need to file update first. So after updating, it will be like another 100 megs or something like that. So I'm just doing that. And with this way, we could troubleshoot the missing libraries, like if we don't know like the packages. This is like an easier way, There are all kinds of other things. So if we do like app file libgl, we have all kinds of candidates, and one of them should be libgl1, which is what I installed. So this is how it works, and everything is great and fine. However, look at like the overhead here, almost another 100 megs. One more thing about size, you saw that I used the no install recommend. To be honest, once graphic is involved, and especially once heavy frameworks are involved, and a lot of people who see like these kind of videos want to do like Node.js, including like one of my customers, we're going to do an Electron project now. I've managed such, but it's been a while since I were really active in developing such. They're super heavy. You do nothing and you get like 1 gig of code. It's ridiculous. So, but people like it, people want it. So when you start writing something, and I think I'll do another video about it maybe, you see that there are like missing dependencies and it's a good way to debug. Now, because everything is heavy, then yeah, so to help yourself get more for less, of course, for more space, you can just skip the install recommend, install whatever in most things, and that's it. Problem is that if you just need a small audio dependency, could install the entire X framework, even if you don't use X at all. And this is part of it. So to summarize that, so basically this is the Docker file that we had here. Okay. So I installed libgl1 because I knew that I needed it. So this is what I will have. And it ran automatically because this was the command. But now that I install it, I can also put this guy. And so I could build like this Docker file, which I did. And the way I ran it, just one last thing, was as follows. I built it and I called it Wayland client test. But look at these fellows. We have here the runtime tier, the bind mount from my host to the target, the Wayland display, okay, and an environment variable to tell me which Wayland display to use. These are important because this way I can go ahead and forward like the Wayland graphics actually connect to wherever I need to connect, which is great. But there is another thing that is needed here. The folders, the libraries themselves, the graphical libraries themselves that were installed as part of like the apt install, simply because for rendering and doing computations, we need to use this API. Let's say we want to draw a cube. We wouldn't have the API for that, so it's in user space library. But the last thing is actually the video devices. Okay, we need to get access to dev.dri. All right, and if we look at dev.dri here, we can see that it has a major 226. When I talked about graphic accelerations and what GPUs are and so on, both in the physical meetup and I think also like in the videos where I showed how to put like a full desktop, I think on a PSG debug or something like that. It's been it's been I think like half a year ago, maybe even more. Then I explained the importance of like the card node and like the render node. So if we do not provide a way to access the node itself, you cannot use hardware accelerator. Okay, so the idea is to provide the node, and the good way to do it would be with dash dash device and then do this guy here. Okay, however, maybe we do not want to just provide everything. Okay, maybe we want to be very specific about things, so we can do bind mount and then just give the particular rules inside it using the device-cgroup-rule. You can see it in the current documentation, in the cgroup v1 documentation. There's some text files over there. You can probably Google it. Hey, it's 2025. You can ask any LLM of your choice, right? AI words. Ooh, we'll be the only one with jobs at the end. No, I'm joking. Everything will be fine for everyone, I hope. So this simple bind mount and the device group rule provides access to all the devices that has a major value of 226. That is like for the video, all the card per device like that. You can definitely see it by looking like this, correct, 226. You can see that it's like for the DRM, which explains very well what we need. If we wanted to also pass video, we could go ahead and just give as device dev input. And if we wanted to have video accelerator, we could also get a dev video, probably. I'm not even talking about it. And for some devices, let's say for example, on NXP IMX8, you will also need to provide a DevGal core that stands for some hardware acceleration and buffers and stuff. And yeah, and this is like how you could do it. You could, of course, instead of all these fellows, run this with dash dash privilege, and then dev is completely exposed, and you get everything like for free. So yeah, so that's what I wanted to cover here. And since I've done that, I will also go and show another example that builds on it for running Electronauts. There are some different, actually, maybe I'll also show some troubleshooting if I craft like a Docker for that. So I hope it's been useful, and that's it.